All right, let's keep looking at these and seeing what we see. So I look at this, and first thing I notice is that this has an equal sign. And it's a quadratic equation because it has a square. That means I'm going to have to solve. But I can't solve unless it's in standard form. That means everything has to be on one side of the equal sign and 0 has to be on the other. So, in this case, because this is my squared term, and it's already positive, and you know me, I like to keep it positive whenever possible, I'm going to go ahead and move this 54 over. Remember, when he comes across the equal sign, his sign changes, so he'll be positive. Now, this is in standard form. So now I need to get out my factoring rule sheet and work my way down. Rule number 1, any greatest common factors. Well, this one doesn't even have a number, so I can't do that. This one doesn't even have a letter. Remember, I'm just ignoring this for now. Doesn't even have a letter, so I can't do that. So no greatest common factor. Rule number 2, is it a binomial? Well, it is not, so it's not a difference of squares. Is it a trinomial? Yes, it is. Is this positive? Yes. Can I get an even square root of d squared? Yes, that would be d. Can I get an even square root of 54? Let me see. Again, 7 times 7 is 49, and 8 times 8 is 64. Oh, we just went right over 54. So, no even square root of 54, so it's not a perfect square trinomial. Then I go on to rule 3. Turn the video off and decide whether this is rule 3a or 3b and come back and find out whether you get it right. Okay, it's rule 3a because my squared term, the term with a 2 or 3 or 4 in it, has a 1 coefficient. So, double bubble. Only in this case, remember to put your zeros, so when you get done with the factoring, you remember, oh yeah, I still have a little more to do. Put a d in the front of each. 1 times 54 is 54. Find all the factors. 3 is 24. 8. 4 doesn't go into it. 5 doesn't. 6 times 9, 7. Okay, that's everybody. So, now I'm looking for 15. Oh, let's do this one. That would have to be plus 3 minus 18. When I add those two together, I get negative 15. That's what I want. Last critical step, positive times a negative. That's a negative. Oh, crud. Once again, I got the wrong pair. Ooh, fortunately, I have another pair I can try. But see how important those two steps are? Make sure you're doing them every single time. So, negative 6, negative 9. That's an addition problem whose signs are the same. Add the numbers, keep the sign. We get negative 15. Last critical step, negative times a negative is a positive. That's what this is. So I can just drop these right in here. Set each of these equal to 0 separately. Keep them far apart so they don't clutter each other up. And so our final answer is D equals 6 or 9. Okay, let's go on and look at another example. Rule number 1. Oh, first of all, let's notice again, it's an equation. Got an equal sign. It's a quadratic equation. So we need to put it into the standard form. Ax squared plus bx plus c equals 0. So this one is already in standard form. Everything is on one side, 0 is on the other, so it's already. We don't need to do work to get it in standard form like we did this one. So now rule 2. Yeah, Rule 1. Any greatest common factors? Well, this one doesn't even have a number. This one doesn't even have a letter, so no Rule 1. Rule 2, is it a binomial? Nope. Rule 3, still Rule 2. Is it a trinomial? Yes, it is, but that's not a positive. So now we know it's not Rule 2. Difference of squares are perfect square trinomial. So Rule 3, well, again, turn this off. Decide whether you think this is Rule 3A or 3B. Okay, so because our squared term, the term with a square in it, has a coefficient, the number in front of the letter, more than 1, anything other than 1 makes it Rule 3B. So now we take the 3 times the 10, find all our factors of 30, that's all of them. Now I need to find the pair that when I add them together I can get a 1. Let me see, it's going to have to be positive 5, negative 6. Cover this up, add those two together. That's an addition problem whose signs are different. Subtract the small number from the big number, so 6 minus 5 is 1. Keep the sign of the big number, so I get negative 1. So that works. Multiply, again, not your numbers, just your signs. Positive times a negative is a negative. That's what this is. But because this is Rule 3B, I'm going to stretch this middle term. Ooh, I think I'm going to put the 6 with the 3 and the 5 with the 10. Again, you can do it any way you want, but if it doesn't work, rearrange it and try again. I just like to get it the first time if possible. That's what will be the easiest for me, I hope. Okay, now we've got 4 terms, so we're going to factor by grouping. Okay, so I can get a 3y out of this. I'm left with y minus 2. Bring this sign down. I can take a 5 out. I get y minus 2 equals 0. Remember to write that. Now my greatest common factor, y minus 2. And I'm left with 3y plus 5 equals 0. Okay? Now it's completely factored, so I just set each of my factors equal to 0 separately. Keep them far apart. And solve. And our final answer, y equals negative 5/3 or 2. So, this is all about Rule 3A and 3B. Next, we're going to go on to special factoring forms, patterns.